Hello students, I am Alpa Rupala, Assistant Professor from LG Institute of Engineering and Technology, Computer Department. Welcome to the lecture series of Mobile Computing and Wireless Communication. Starting with the Unit 1, Introduction. Topics to be covered in this lecture. First of all, the introduction of wireless communication, then introduction of the mobile computing, then what are the signals, type of signal, the time domain concept of the signals and frequency domain concept of the signal. So first of all, what is the wireless communication? The basic term of communication means that you want to communicate with someone or some another person at any place. So what we are communicating, we can send data, we can send voice and anything, whatever we want to. Okay, so basically the wireless communication involves the information transfer from one place to another place. Now this can be wired form or this can be wireless form. So what is the wired and wireless form? You also know that we are having two types of communication channels available, wired communication and wireless communications. So wired communication means we are transferring data via any physical medium. It could be wires, it could be cables, or it could be any form of the conductors. But the wireless communication means we are transferring the data from one place to another place without having any communication physical medium. So how this medium, if we are not having any physical medium, then how the data can be carried out? It can be carried out by the form of electromagnetic waves, which is called as the signals. Nowadays, we know that we are all having the home network in which we are connected with the Wi-Fi. Now, your laptop and mobile phone is connected with Wi-Fi, your PC is connected with Wi-Fi, your printer is connected with Wi-Fi, or any another wireless medium which can be connected through this Wi-Fi. So, basically, what we want to communicate, we want to communicate at very small distance devices, or we want to communicate with very large distance devices. Large distance can be a radio communication also. As you can see in this example pictures, here one is the telephonic communication and here is the home network communication. So where this wireless communication can be used, it can be used as a GPS unit, it can be used as a wireless keyboard, handsets, radio receivers, satellite television, broadcast television, cordless telephones, etc. Introduction to mobile computing. First of all, we need to understand the term mobile. Mobile means anything which can move or which is movable. Okay, but we want to connect or we want to use our technology while we are moving, and this is what known as mobile computing. It is the human-computer interaction devices which is in the form of the wireless communication, and we are using it while we are mobile. Mobile computing involves mobile communication, mobile hardwares, and mobile softwares. Combining these all things, we can create a mobile computing using wireless communication. So here are some different names of mobile computing: any wearable device, any normal computing device, global service portability devices. These all are under the mobile computing. So now moving forward to our next topic, that are signals. And signal is a electromagnetic waves. It can be a function of time or it can be a function of the frequency. So on the basis of that, we are having two domains of the signals. First one is time domain and second one is frequency domain. So first of all, we are learning about the time domain concept of the signal. The signal can be viewed as the function of the time. And electromagnetic signals can be of two types: analog signals and digital signals. So first of all, what is the analog signal? Analog signal, as you can see in this picture, any form of signal in which we can calculate the strength of the signal at each interval of time, at micro interval of time, I can say. So the signal is varying in a very smooth manner, and this is known as analog signal. We are not having any break in the signal. So you can see diagrammatically we can represent it like this. We are using the time domain concept. So here is the time parameter in which we are calculating the strength of the signal, and which is the form of this signal and known as the analog one. Same as we are having the digital signal, in which the signal intensity, or we can say the signal strength, is divided into levels of strength of your signal. Like for some constant period of time, the signal is having one constant level, and for another constant period of time, signal is having at another intensity of level. So we can represent the digital signal like this. Here we are having the time domain concept, so the time at x-axis, and this is the our level of signal at 0 interval to 1 second. If I can assume that this is the 1 second, from 0 to 1 second, the signal is having no intensity or no strength, but at 1 second to 2 second, it is having some amount of strength. Suppose we can calculate it in a volts. So let us assume that it is a 1 volt or 2 volt. Same as we can also divide the signal into two another forms. We can say the signal can be periodic signal or signal can be aperiodic signal. So what does the periodic signal means? The periodic signal means the signal repeats its pattern over a particular interval of a time. And it can be represented by one formula which is shown here. S of small t plus capital T is equals to S of t, where t can be from minus infinitive to plus infinitive. And it is capital T, the period of the signal. We will see about what is the capital T in later on. So here you can see we are having one periodic analog signal and periodic digital signal. Yes, the signal, periodic signal can also be divided into a periodic analog signal and periodic digital signal. So here, at particular interval of time, from here to here, our signal is repeating its pattern. Look, one signal and same signal is repeated for fixed amount of interval of time again. See. So here from this interval point to this interval point, this is your small t, and which is having the continuous same pattern. And same as we can conclude on the digital one, for fixed interval of time, the signal is repeating itself like this. An aperiodic signal which does not satisfy any form of the formulas which we have learned earlier like this. This is our formula, and aperiodic signal does not satisfy any kind of the formula. Aperiodic signal does not repeat itself at any interval of point. Here it is some more example on periodic signal. Shown here is sine wave, complex wave. It can be anything, but it is repeating itself. A triangular wave, square wave. So in time domain concept, obviously we need to understand what are the terms we can use and represent the signals into a graphical form. So here are the first term, amplitude. Amplitude means strength of the signal, or we can say intensity of the signal. What is the strength or intensity? It can be calculated or measured in a volts. That means at particular interval of time, what volts of strength your signal is having is known as the amplitude of the signal. Okay, so the next term is peak amplitude. What is the peak amplitude? Peak amplitude means at full interval of time, the maximum value or strength of your signal is known as peak amplitude. Next term is frequency. So now frequency can be measured by two parameters. It can be measured in cycle per second or it can be measured in hertz. Now what does the frequency means? Frequency means at what rate your signal is repeating itself. At what rate your signal is repeating itself. See, suppose I am considering one fixed amount of time, and at that amount of time my signal is repeating 3 times. So my frequency is, I can say, 3f. Now period capital T. As we have discussed earlier, capital T. So here it is the period capital T. It is the amount of time it takes for a signal for single repetition. So these two fundamental contradict each other. See, frequency small f and period capital T contradict each other. That means we are having the reciprocal relationship between capital T and small f. So we can conclude that capital T is equals to 1 upon small f. Here in diagram, at this particular interval of time, my signal is having this amount of strength. So this is my amplitude. Okay. And at this particular interval of time, this is the amount or intensity of my signal. So this is the another amplitude value. And we can say this is the peak amplitude because no one other spike is having that much of strength other than this. So we can say it is a peak amplitude. Okay. Now from here to here, this is our one cycle of a signal which is repeating itself from here to here, from here to here. So we can say the amount of time required for transferring our one single signal is known as capital T. Okay. Or we can say for 1 second, number of signal can be repeated is known as frequency. But we also know that the frequency and period is reciprocal of each other. Next term is phase. So the basic definition of phase means the phase is measure of the relative position in time within a single period of a signal. But let's not go through the proper definition. We are seeing one diagram in which we can learn phase in a very easy manner. Like I can say for my one single pattern, the start point of my signal, from where my signal is repeating itself, it is having what intensity of value. Okay, I repeat, what intensity of value at the start point of my signal. So look over here, this is the basic diagram of a single sine wave signal. Okay, in which if my signal is starting from this particular point, look at my pointer. If starting from this particular point, then I can say my phase is 0. If it is starting from this point, then I can say my phase is 90 degree or pi by 2. If it is starting from this point, then I can say my phase is 180 degree. And if it is starting from this point, then 3 pi by 2. And if this point, then 360 or 2 pi. Okay, so by this diagram, we can conclude what the phase means. Sine wave calculation, the generation sine wave can be written as S of t is equals to capital A sine 2 pi ft plus phi, where capital A is a amplitude, small f is a frequency, and phi is the phase of your signal. So we can represent our signal by these 3 values. Now we are representing one diagram in which the frequency of your signal is 1 Hz and the period of your signal is 1 second. See in this diagram, amplitude is also 1 volt, frequency is 1 and phase is 0. So our signal will start from this point. It will go to 1 volt value, maximum peak value will be 1 volt. So it will reaches to 1 volt and will go down after that, and the frequency is 1. That means for 1 second, only one signal will repeat itself. Only one signal will repeat itself. Same as we are seeing another one example in which the frequency is 1, phase is 0 as previous, but the amplitude value is 0.5. So our peak amplitude is 0.5. So starting from same point to 0.5, then repeating itself in a 1 second, only single interval, single repetition, as our frequency is 1. Same as, suppose we are having frequency value as 2. Okay, so that means for 1 second of time, my 2 signal will repeat itself. My signal will repeat itself twice. This is the 1 and this is the second. Amplitude is 1 only. Okay, so 1 second, in 1 second, my signal will repeat twice. Next, in which our phi value is pi by 4. Phi value is pi by 4. So that means, okay, our signal will be start from so next is phi is pi by 4. So and amplitude is 1, frequency is 1. So our signal will start from this point. Look, this point. So our signal is starting from this point, pi by 4 value. And it will repeat itself till here. Starting from here, ending till here. So next important term, wavelength, which can be represented as lambda. The wavelength of a signal is a distance occupied by a single cycle. Okay, we can see this is my single cycle starting from here to here, suppose. Then this will be the wavelength of my signal. Okay, and suppose the velocity of your signal is v, then lambda is equals to small v into capital T. Capital T is your period. In frequency domain concept, we understand a signal as a multiple combination frequency signal. You can see in diagram, I have represented only a one signal, but which is the combination of multiple frequency signal. But in real life concept, we cannot represent frequency domain signal in a paper. Okay, just by an example, I will try to understand you the concept of the frequency domain. Suppose this is my representation of signal into the mathematical form S of t is equals to 4 divided by pi sine 2 pi ft plus 1 by 3 sine 2 pi 3 ft. This sine 2 pi ft is a one signal and 1 by 3 sine 2 pi 3 ft is another signal, and what we representing is S of t, which is the combination of two frequency signals. So here we are seeing the diagram sine 2 pi ft. That means amplitude is 1 volt, frequency is small f is equals to 1, and time interval capital T is 1 second. Okay, so our signal will repeat itself only one time. Okay, now next is 1 by 3 sine 2 pi 3 ft. 3f means now my frequency is 3. Now my frequency is 3. So that means in 1 second time, my signal will repeat thrice. 1, 2 and 3. But the amplitude value is 1 by 3. That means approximately 0.33. And what actually we are moving or we want is S of t, which is our the signal, which is the combination of signal 1 and signal 2. And here it is what our signal 3. Important terms regarding the frequency domain. First term is fundamental frequency. When all the frequency component of a signal is integer multiple of a single frequency, then it is known as fundamental frequency. In our previous example signal, look here it is what? 2 pi ft. So our first signal frequency is small f and second signal frequency is 3f, and it is a multiply of this f by integer multiple 3. So we can say this small f is a fundamental frequency. So our concluded signal will have the frequency as the fundamental frequency. The spectrum of a signal is a range from frequencies it contains. Like in our previous example, the frequency is from small f to 3f. So the spectrum will be from f to 3f. And the bandwidth of the signal is represented as maximum frequency of your signal minus minimum frequency of your signal. So in our previous example, 3f minus f is equals to 2f, and this 2f is representing the bandwidth of your signal. Okay, like in previous one, the amplitude, frequency and phase can be represented on a signal on a paper, but in frequency domain we cannot represent spectrum, we cannot represent bandwidth. So now some important difference: periodic signal and aperiodic signal. Difference between periodic signal and aperiodic signal. So the periodic signal is which repeat itself for a specific interval of time, but aperiodic signal does not repeat itself. The periodic signal can be represented by mathematical equation, but aperiodic signal cannot be represented by mathematical equation. In periodic signal, that value can be determined because we are having the equation. At any point of time, we can calculate the strength of the signal by just replacing the small t. But as in aperiodic signal, we are not having any mathematical equations, so we cannot determine what will be the value at particular interval of time. Periodic signals are deterministic kind of signal which are determined to repeat itself. But aperiodic signals are the random one, it can be vary in any form. So some of the examples of the periodic signals are sine wave, cosine wave, square wave, and aperiodic signal can be any sound signal. So the summary of this particular whole fundamental, we have learned about what is the mobile computing, what is the wireless communication, why we are learning this subject, then what are the signals. There is a definition of the signal, analog and digital, then periodic and aperiodic signal, then time domain concept. The important terms regarding the time domain concept were amplitude, frequency, phase and wavelength. And in frequency domain, fundamental frequency, spectrum and bandwidth. So, thank you. We will meet in our next lecture.